Hello students, how are you? I hope you all are doing well. In this lesson, we are going to study about what onto and into function is. Specifically, I'm talking about classification of function, which bifurcate what is a surjective and what is a non-surjective function. So let's get started with it with its definition part. See, if I want to define onto formally, then this function is defined from the non-empty set E to a non-empty set B, such that every element in V is the F image of at least one element in A. That means there will not be any single element in set B which is not the F image of any element of set A. Since we know it is a function, so every element of set A will participate there. And if we look at from set B, then none of the element will remain empty, which is not participating in the function. Basically, if you don't like this definition, so you don't have to worry, because there is another way we can correlate or we can define onto function, though meaning of both the definition will remain the same, because our concern is more about there shouldn't be any element left whose pre-image does not exist. Just have a look on this mapping before I give you another definition. In this one, as you can see, I have defined three mapping from set A to set B, from set A to set B. So if I ask you which of the following will represent onto function, obviously, first, it does represent onto or surjective. Second is also an example of onto function, but third one is not. Why? Because there are two elements from set B, which is not the pre-image of any element in set A. Or if you are good with the codomain and range part, then basically we used to say that set B, elements of set B is said to be codomain, and elements which are participating in particular function are said to be the range. As we said, none of the elements should remain empty there. That means I am stating that range of that function should be as same as of its codomain. So if range is equals to codomain, basically this is what we are focusing upon. Range, if you come to find out range of that function, somehow if you prove that it is equals to codomain, that means we are ready to comment whether function is on to or not. Just have a look on a bunch of example before I give you insight about what into function is, and a bunch of assumptions which will help you out to not only to save your time but to create your own theory regarding onto function. Just have a look on this one. We have a function from all rational to rational number. Function fx, it is defined as 2x plus 3. We need to check whether this function is onto or not. To check whether your function is onto or not, it is as good as checking the what will be the range of that function. As we know that we are free to choose any rational value. If I am free to choose any rational value, this is my question. Well, the output of 2x plus 3 will give me every possible rational number. For example, if I am wondering whether I'll get a output or like 2021 or not, then definitely there will be some certain rational x for which I'll get 2021. For more example, if I want to check whether or not I'll get 1 over 2022, then by shifting this 3, I think easily I can find out some rational value of x there. It suggests that if x is your rational, then it indicates 2x is equals to q minus 3 will be a rational number. That means for every possible rational value, I will end up getting a rational value. That means your function is on 2. But have a look on the second one. This time I'll be substituting a different natural number, and its codomain is natural number. So I wonder whether I'll get all natural numbers or not. Suppose I want to there are two different way I can check the range of that function, where in set A I'll be uh, you know putting different natural values, and in set B let me write down or elements of natural number 1 2 3 4 5. Suppose I substitute x is equals to 1 there, then at x is equals to 1, output will be 5. For 2, I'll get values which is greater than 5. For 3, greater will be there. As I proceed, then what will happen? There will not be any chance that I'll get values like 1, 2, 3, 4. This particular value will left out from your range. Correct. So this element, it just indicate that a part of range, a part of element is not participating in codomain. Hence, range is something which is not equals to codomain. Am I right? So if it is not equals to codomain, then we would say your function is not onto. So if it is not onto, then what it is then? Say along with onto, functions which are not onto are usually called into function. So you don't have to dwell in whether your function will be 1 1 or minimum. For that one, I have created another video. If as far as your onto is concerned, you will be checking whether it is onto or into. If it is not onto, then by default it will be a into function. So in into, obviously there will be some element in B which will not be the image of any element in set A, or from that non-empty set from which you are defining your function. Or if you want to check your function using the definition of range in codomain, then obviously range will not be the part of, will not be equals to codomain. Obviously it will always be the subset of codomain. So here are a bunch of assumptions which you may use while solving any question, or this little help, it will contribute a lot. For example, if we have any polynomial of even degree. So if it is a polynomial, let us say if we are talking about quadratic equation, now relation is defined from R to R to, or R to R to R to R only. So if it is from R to R, then there isn't any way I will end up getting range equals to R, because I know if range is concerned for a quadratic expression, then it is from negative d by 4a to infinity, or from negative infinity to negative d by 4a. But if there is a polynomial of odd degree from R to R, then obviously for a greater value of X, I'll get greater outputs, and for smaller values of X, I will get smaller output. That means the graph of a odd degree polynomial will touch or will tends to infinity, as well as to negative infinity for different values of X. So that will make your odd degree polynomial onto within R to R only. But if it is a quadratic over quadratic polynomial from R to R, then obviously this will not be something which is onto. I have figured out a bunch of or question based on range, where we try to calculate the range of quad over quad. So do check this video if you find it relevant. Apart from these 2 points, if from function R to R, if fractional part of X, greatest integer of X, mod X, even signum X is concerned, then they not none of the function will be onto one, because we know that a kind of function have some certain limitation based on the output. Your fractional part X, which will give you values from 0 to 1. Greatest integer will only entertain integral values, wherever mod function will give you values from 0 to infinity only. Wherever signum function, it will either give you positive 1, negative 1, or 0 only. So for R to R, this function is not set to be on to 1. Let me take one more example. Say this time we have fx is equals to sin x. And if I are defining function from R to R, then definitely this will not be a onto function, because we know sin x can give you output from what? From negative 1 to positive 1. But if I define this function from R to negative 1 to positive 1, then this time your codomain will be equals to your range, or your range or codomain will be the same. So for that case, your function is set to be, it's set to be on 2. Wherever if I'm try to change my domain this time from R plus to negative 1 to 1, then I just need to draw to the graph of sin x in R plus region, and need to check whether I'm still getting the range of the function from negative 1 to positive 1. If it is, then my function is set to be the on to 1, as you can see in the graph 1. But if I'm again modifying my domain, this time it is from negative 1 to positive 1, and I'm wondering what values of whether range still will be equals to negative 1 to 1 or not. So for that one, I need to draw the graph of function sine x within that input from -1 to +1. As I know, this input will be count as a in radian, and what is the relation in radian in degree? Then I know 1 radian is approx to 57 degree. So let me draw the graph of sine function from -57 degree up till +57 degree. As I know that at positive 57 degree, I'll get value approx to √3/2, or let me just mention it with sine 1 radian, which is smaller than 1. And similarly for sine -1 radian, it will give you value negative sine 1 radian, which is not close to -1 to 1. That means the domain is not equals to range this time, so this function is not on 2. But if I modify my function, let us say this time my function is sine 2x, and again I am feeding the input from -1 to +1, and let me check what will be its impact on its range then. If input is from -1 to 1 for 2x, then eventually I need to draw the graph of sine x from -2 to +2. As I mentioned earlier, 1 radian is will contribute around 57 degree. So 2 radian will be approx to 114 degree. So now let me draw the graph of sine function from 11 -114 degree up till positive 114 degree. And if I try to find out the range of the function, then obviously this time it will be from -1 to +1, which will correct -pi/2 to +pi/2. So this will make your function on 2. I'm sure you got my point. What is my direction or orientation? So let me check one more. This time on gx is what I'm working on. Function is from R to R. See, we have 2x plus 2 times mod x. So first of all, I need to define this function piecewise. So for gx, it will be equals to 2x plus 2x, which is 4x only when x is greater than 0. Function will be equals to 0 when you put input is 0. Wherever it will be still be 0 when you put still values which is lesser than 0. So the graph of gx will look like something like this. It will be a straight line for positive values of x, wherever it will be just a line, or it will overlap your x-axis for all values of x which are lesser than 0. As you can see on the graph, that there is no way you can reach, or your range will be equals to real number, because in that case you will miss out all the negative outputs. So thereby your function is not surjective. So thank you very much for you, and this is for this for the video.